Hi. Here we already have that. Okay. Question is how many 4-digit numbers greater than 1000? Okay. And each having all 4 digits distinct are there with 7 coming before 3. So we know in this 4-digit number 7 and 3 will definitely come. 7 will come before 3. So what we need to do is we need to select 2 more digits out of the remaining digits. The remaining digits are 1, 0, 1, 2, 4, 5, 6, 8 and 9. So we have total 7 digits. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 digits, right? So out of these 8 digits, we need to select 2 more digits. So we'll have 2 of these selected digits, 7 and 3, to be arranged such that 7 comes before 3. So here we'll have to make 2 cases. Case 1, when 0 is selected, out of these 2 numbers, if 0 is selected, we'll have to make a case for that. Why 0? Because if 0 comes at the leftmost digit, then the number will not be a 4-digit number, right? So that's why we are considering 0 separately. And then you have case 2, when 0 is not to be selected. Okay? Now let's take the first case. In the first case, we already have a 7 and a 3, and if 0 is selected, what we need to do is we need to select one more digit out of these remaining 7 digits, right? So that can be done with one more digit, let's say x. This can be done in 7C1 ways. Out of these 7 digits, we have to select one digit. So the number of digits, the 4 digits can be chosen in total 7C1 ways. Now we have these 4 digits such that 0 cannot come at the leftmost digit and 7 should come before 3. So let's do one thing. Let's arrange all these numbers to form a 4-digit number. So if you have a 4-digit number 1, 2, 3, 4, the leftmost digit can be, right now I'm not considering this condition, I'm just making all the possible numbers. So this leftmost digit can be filled by either 7, 3 or the digit chosen. So this can be done in 3 ways. Now 0 cannot come here, that was the condition. And the remaining 3 digits can be filled by the remaining 3 positions can be filled by remaining 3 digits in 3 factorial ways. Right? So the total number of ways is 3 factorial 6, and 6 into 3 is 18. So if this is the number of ways of choosing the digit, and for each selection we have 18 ways of arranging the numbers. So the total number of numbers is 7C1, which is 7 into 18. 7 into 18 is 126 numbers. Okay. So although we have got 126 numbers, but here we have not satisfied this condition. So now let's look at this condition. Now out of this 126 numbers, there will be few numbers where 7 will be before 3, and there will be few numbers where 3 will be before 7. Now the numbers which are 7 before 3, will they be more than the vice versa, 3 before 7, or the other way around? Well, there is no bias why numbers with a 7 before 3 would be more than numbers with 3 before 7. Both of them should be same. So out of 126, there will be half 63 numbers which will have 7 before 3, and there will be half 63 numbers with 3 before 7. They will be equal, right? There is no bias for 7 or 3. So out of this 126 numbers, 63 numbers will have 7 before 3. So from this case, we get 63 numbers. Now here when 0 is not selected, so we already have 7 and a 3, and we have to select 2 more digits, let's say x and y, out of these 7 digits. 0 cannot be selected now, right? So selecting 2 digits out of 7, this can be done in 7C2 ways, right? So now I have 4 digits and I have to make 4-digit numbers. So the number of ways of forming a 4-digit number is, when you have 4 digits, 4 factorial. So the total number of numbers will be 7C2, which is 7 into 6 by 2, into 4 factorial, which is 24. So this becomes 6 goes by 2 3 times, 7 into 3 is 21, 21 into 24. So 21 into 24 is 480 plus 24, 504. Now out of these 504 numbers, there will be some numbers which will have 7 before 3 and there will be some numbers which will have 3 before 7. And both the type of numbers will be equal because there is no bias. Why should 7 come before 3 more times than the other way around? So we'll have equal number of numbers. In 250, half of 504. In 252 numbers, 7 will be before 3. And in half of the numbers, 252 numbers, 3 will be before 7. So from here, I get 252 numbers which will have 7 before 3. So the final answer is 63 plus 252, which is 315. So there are 315 numbers, 4-digit numbers with each digit distinct such that 7 comes before 3.